This is the third part of properties of set operations and relations, and here we are going to discuss the third property, which is associativity of union and intersection. So this property says that A union B union C equal to A union B union C, and we have to prove this. Second is A intersection B intersection C equal to A intersection B intersection C. So again, you should know what is the meaning of union and intersection. Then this property is very easy. So union means if suppose we have two sets, you have to write down each and every element of both the sets. In intersection, we have to write down only common which are present in both sets. But keep in mind that always you have to solve whatever is in the parenthesis, right? Whatever you have in the parenthesis, it is B union C, it is B intersection C. So we have to solve first this. Okay, we will start from the first property. Here I will write down set A. Suppose in set A we have 1, 2, 3 and 4. Make it simple. You can write down anything. In B, you have suppose 1, 2, 6 and 7. And in C, we have suppose 1, 8 and 9. Because why I have made this A, B, C? Because we have three sets A, B, C. First, we are going the first to prove the first part, that is A union and then in parenthesis B union C is equal to. So I will write down here A union B union C. This is the left hand side. See, this is the left hand side. First we will find out this, then we will prove that it should be equal to A union B in parenthesis and then union C. So I told you first you have to prove B union C. So B union C, whatever is in the parenthesis. I will not write down here, but in your practice, in your books, you have to write down B and C here. So this is B and C. See, B 1 is common, but you have to write down only one time. 2, 6, 7, 2, 6, 7, 8 and 9. Each element of both the sets B and C you have to write down, but if something is common you have to write down only one time. This is B union C. Now A union B union C. Now see, you have to compare this B union C with A, this one. So in A we have 1, 2, 3, 4. So write down 1, 2, 3, 4. But in B union C we have also 1 and 2, but we will not write down because only one time. Then 6, 7, 8, 9. 6, 7, 8 and 9. So this is the left hand side. A union in parenthesis multiply by B union C. This one. 1, 2, 3, 4, 6, 7, 8, 9. Now we have to see whether it is equal to A union B union C or not. So for the right hand side, I will do it here. Right hand side. First you have to prove A union B. A union B. Whatever is in the parenthesis, we will solve first. So again, union, each and every element 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 6 and 7. Because 1 and 2 are present in both the sets, but we will write down only one time. Now this is A union B, and you have to take the union with C. This is the right hand side, this one C. So this you have to consider this A union B and C. So see, 1 is also here in C, 1 is also in A union B, but we will write down only one time. And then 2, 3, 4, 6, 7. These are the members of A union B, and 8 and 9 belongs to C as well. We have to write down each and every element of both the sets. But if something is common, just like we have one common, we will write down only one time. So this is the left hand side and this is the right hand side, and you can see 1 2 3 4 6 7 8 9, 1 2 3 4 6 7 8 9, both are same. So the first condition of the associativity of union and intersection is proved, that A union into B union C is equal to A union B into U union C. But again, keep in mind, you have to solve whatever is present in the parenthesis first. Now come to this second part. Here is the intersection. First, we will prove this one, left hand side. So left hand side is equal to A intersection B intersection C. So first we will prove B intersection C. Write down B intersection. Intersection means which is common between B and C. So one, only one is common. Okay, one. Now we will take the intersection of B intersection C, this one, which is 1, with A. And again, this is A1 and 1 common. Intersection means common, which is present in A, this is A, and which is present in B intersection C, which is 1. So this is the left hand side. Now right hand side. Right hand side, it should be equal to 1. A intersection B intersection C. First you have to prove A intersection B. So A intersection B means common, A and B. So what is common? 1 and 2. See, 1 is here, 1 and 2 is also here. So 1 and 2 is common between A and B. Now you have to take the intersection with C. Right, this is A and B. You have to consider this one now. A intersection B, 1 2 with C. So only one is common. See, 1 is here, 1 is in the C. 2 is here, but 2 is not in the C. Similarly, 8 and 9 are present in C. 8 and 9 are not here. So only 1. So see, this is the left hand side one. This is the right hand side. Both are equal. So we can say A intersection into B intersection C is equal to A intersection B into intersection C. We have proved these two properties of the associativity of union and intersection. Again, whatever is present in the parentheses or in brackets, you have to solve first. Then you can move on. Right, but still, if anything is not clear, you can write in the comment section and I will try my best to solve it. But please do not forget to subscribe to my channel Saima Academy, and thanks for watching.